Welcome to this video lecture. Myself Atul Kumar, working as a assistant professor in Department of Computer Science, Rajiv Gandhi Memorial, Government College, Joginder Nagar. This is the lecture number 1 of relational algebra. So relational algebra is a procedural query language. It is basically the collection of operations that are used to manipulate operations. They are also called as tables. So it was firstly introduced by Dr. E.F. Codd, and the query in relational algebra specify not only what information is required, but also it specify how to get the information. So it means that procedural query language specify what information is required and how to get that information that is also required in procedural query language. So it is capable of performing operations pertaining to information retrieval and information update. So there are different kind of operations in relational algebra. So the firstly I will discuss the basic set operations in relational algebra. So basically these are set operations and they are derived from mathematics or mathematical theory. All the relational operations or basic set operations are binary operations. Binary means they operate on two tables or two relations, that is they are applied to a pair of relations. So basic operations in relational algebra are set union operation, intersection operation, Cartesian product operation, set difference operation, Cartesian product operation, and rename operation. So firstly, what is union operation in relational algebra? It is basically same as that of mathematical as be used in mathematical form. So basically it is represented by this symbol, union symbol, and it contains or include all the tuples, means all the rows that are both in A or B, but it eliminates duplicate row. So it contains all the rows in A and B and without containing duplicate row. So for a union operation to be valid, there are different conditions. The first condition is, suppose we have two relations R and S. So these two relations R and S must be of same number of attributes. This means they have same degree. What is the degree of a relation? The degree of a relation is that the total number of attributes contained in that operation. So both R and S relations must have same degree. That means they have same number of attributes. The second important property or condition is attribute domains need to be compatible. Means if suppose we have a attribute, suppose a date of birth in a relation, so that attribute contains a date, so that the domain of that attribute must be compatible with the other relation. Next important property is duplicate rows or tuple should be automatically removed. So when we apply a union operation on two relations, then the duplicate tuple should be automatically removed. So here is the example of union operation. We have two relations, one is A and other is B. The first relation contains 5 tuples and the second B relation contains 4 tuples. So basically when we apply a union operation on this, so it contains all the rows in A and B, but it removes or eliminate duplicate rows. And in this case we have a duplicate row, yes, we have a duplicate row D and 3, and here in relation B we have same row D and 3. So we just in union operation only one entry is allowed for this d3 row. So this row is added only once, and the duplicate row is easily eliminated or removed in the A union V resulting operation. And also it is a binary operator. Union operator is a binary operator. This means it operates on two relations. So to operate a union operation we need at least two operations. Next operation we have a intersection operation. So intersection operation is defined by this symbol, and suppose it defines a relation consisting or contains a set of all tuples that are both a and both in A and both in B. This means it contains or it results into a relation that contains a row that are common in both A and B. However, A and B must be union compatible. This means the properties that I used for union operation, that is R and S must be same number of attributes, they must be compatible, and duplicate rows should be removed. These properties also followed in intersection operation, and also it is a binary operator. This means for applying a intersection operation we need at least two tables. So here is the example. We have a one relation A and other relation is B. The first relation contains how many rows? There are 5 rows, first, second, third, fourth and fifth, and the second relation contains 4 rows, and there are two attributes or degree of first relation and the degree of second relation is same, so they are union compatible. And when we apply intersection operation, that is A intersection B, then there is only one attribute row that is common, that is D and 3, and also there is also one another row that is A comma 1. So A1 and D3 are the resultant operation A intersection B. Next operation or basic operation in relational algebra is Cartesian product, and it is always be represented with the help of this symbol, that is a cross symbol, and it is basically very helpful to merge columns from the two relations. Generally Cartesian product is never meaningful operation when it performs alone. So to perform a Cartesian product operation, it is followed by some other operations. So it contains all the rows or combination of all the rows from 1 and 2. So here we have a relation A and we have a relation B. So it contains all the rows and attributes or the columns of A and B. So first row is A1, so it is combined with, or A1 is combined with all the rows of A2. So B operation or B relation. So A1 and the second is A1, so it is combined here A1. The second now it is combined with this C2, A1 C2, then A1 D3, then A1 E4. Then the second row we combine this with all the rows of the relation B, that is V2 A1, then B2 C2, then B2 D3, B2 E4. Then we have third row, it is also combined with all the rows of second relation B, D3 A1, D3 C2, D3 D3 and D3 E4. Then we have F4. F4 is combined with rows of second that is F4 A1, F4 C2, F4 3, F4 4. Then we have row E5, and E5 is also combined with all the rows of second relation, called as Cartesian product. So also the degree of if we notice the degree of a resulting relation A cross B is the sum of degree of relation A and sum of degree of relation B. That is, the degree of relation A is 2, and as it contains only 2 columns, and degree of relation is of B is also 2, and the degree of resultant relation A cross B is 2 plus 2, that is 4. 1, 2, 3 and 4. And total number of rows is the combination of all the rows from the two relation. So first row is first relation contains 5 1 2 3 4 5 rows, and the second relation contains 4 rows. The total number of rows in the resultant relation is 5 into 4. So total number of rows is 5 into 4. So in general, suppose we have m rows in first relation and n rows in the second relation. So total number of rows in A cross B resultant relation is m cross n, and the degree, suppose the first relation contains number of columns, suppose x, and second relation contains number of columns y. So degree of the resulting relation is x plus y. So degree of resulting relation we find by adding the number of degree of two relations and the cardinality of the relation, number of rows of the resulting relation uh, is to be calculated by finding or performing multiplication between total number of rows of first and second relation. So the main properties of Cartesian product include it does not need to be union compatible. Again, the degree of resultant operation is the sum of degrees of all relation, as I have discussed earlier. The total number of rows in the resulting operation is equal to the product of number of rows of the first and the second relation, that is here m cross n, and for degree x plus y. So thanks for watching this video lecture.